Hello again, Tom from EveryStepPhysics.com, EveryStepCalculus.com. This is obviously a physics problem, and I'm going to show you how it works on my fabulous programs. In my instructions that I give you for how to run the programs and everything else, I tell you on any written problem you're going to take these terms here and put them off to the side over here. I first tell you to put a square around whatever's asked for, because that's what's going to be in the menu in the program here. But this is ABC, so it's pretty clear. You don't have to. It's all asking for everything here, so you don't need to put a circle around it. But a lot of times it's hidden in problems. You know, when you try to, how long does it take? Well, that would be time. You know, I mean, you'd have to use a little bit of your knowledge to get through these things, and we all like to. So you would pick mass, M equals 4.2 kilograms, okay? K equals 186 Newton over meters, okay? Newton per meter, etc. Here you have amplitude, so you can put an A there if you know my programs, capital A versus small a, because small a is kind of acceleration, but so amplitude, I have it for capital A, 3 centimeters. Now you know that has to be changed to meters, okay? And then they give you y versus y, okay? So I call this y1 and y2. Why not? Something has to be different. They're not the same. How can y be equal to 1.5 and y be equal to 2.5? You know, so it has to be different. y1 equals 1.5 centimeters. You have to convert it to meters. Y equals 2.5 centimeters, okay? So you have this all nice and neat on the side of your paper over here, on your test paper or whatever you're doing, you know, and then you can relate that and look for those variables in my programs as I walk you through every problem in the world in physics and calculus. We click on physics to get to my main menu. I'm already at springs because to save time, because this is a spring operation. Anytime you see a spring word in any problem, you'd go to springs in my menu. Makes sense, doesn't it? I would think so. So we're at spring calculations. Well, there's vertical and there's horizontal and there's at an angle springs, right? So this one happens to be a vertical one. Okay, that seems to be logical. And then I'm already at the variables here. Here's mass, K, amplitude, y1 and y2. All right. Now notice that this x1 and x2 is still in the vertical section of my programs, and because a lot of loser professors or people who dream these problems up evidently don't understand that when you have a vertical spring, then you got the y-axis, and when you got a horizontal spring, you got the x-axis, you know, which is x1 and x2. So, but they are wrong in my estimation. They should be using all y's if you're talking about a vertical spring, vertical axis, you know. So we choose that, and it loads. It's busy down here, says it's loading. And then we're going to enter the variables. You have to press alpha first in my program. So we go alpha 4.2. I have to go very slow on this simulator, otherwise the thing will mess up on me. And I gave you the choice of kilograms, which it is. No, but what if they gave you newtons? Could you convert that to kilograms? I don't think so. You could in my programs. And now we're going to enter the vertical spring stretch past equilibrium point called amplitude. Okay. When you hang a mass on a spring, it becomes equilibrium. It's not moving, it just hangs there. Well, there's a certain amount of stretch, and then when you pull it down further, it will go down and oscillate, called simple harmonic motion, and it'll oscillate back and forth up to the equilibrium point. That's called amplitude. The weight hanging on the spring is called stretch, and then which turns out to be no movement, and then you further, when you stretch it down and let it go, it'll oscillate back and forth. That's called simple SHM, simple harmonic motion, and that's amplitude. So we choose that, and we put it in here. Alpha 3 centimeters. Alpha 3, and then we choose number 2 centimeters, which will convert it to, and make sure you write this down on your paper, on your side of paper. Ooh, 3 times 0.01 is 3. Now we got centimeters to meters. Enter spring constant. Alpha 186. Enter. And I've seen it where they give you Newton centimeters, Newton millimeters, Newton 1,000 Newton, kilonewton meters, foot pounds. All these things are changed to Newton meters, okay? If you didn't have this program, you'd have to know that in the test problem that you're doing or whatever. So you put in here what you see in your paper. And now we're going to enter the Y's. Here's the enter vertical spring stretch, less than the amplitude, called Y, but named X in most formulas, see? So I try to give you some heads up on how these problems work a little bit. And Y is less than the amplitude, so it's within the stretch, you know, or in the SHM, and we're trying to find the time between these two. That took me about 2 weeks to figure that out, and going through 100 professors' problems and try to figure out what the heck they're doing and how they use different systems and whatever, you know. Try to figure out the best system for you and me. So Y1 is equal to alpha. See if this doesn't mess up now. Alpha 1.5 and centimeters. And then the next one is Y2, 2.5 centimeters. So we're going to go alpha 2.5 centimeters. And then I show you what you've entered. 4.203 meters, 186. Everything looks good. You could change it if it was wrong. And then I take you through all the different aspects of it. Angular frequency is 6.6548 rads per second. Frequency is 1.059 hertz. Period is that divided by 1, or 1 divided by that frequency, 0.94417 seconds. That's period. Total energy is, of course, PI. You got to remember these formulas in physics. They always come up. Potential energy, total energy, 1/2 K times A squared, amplitude squared. Here we put them in there, and here we come up with the problem here. That equals kinetic energy. Here where we can get velocity. And so we substitute that stuff, and we got velocity max 0.19964. And now we're going to find the amount of time between here. I tell you the horizontal axis is t, and the vertical axis is y, right? And so yt, this is the formula for the RT formula, for time. And we do the calculations here. Equals sine Wt. That's angular acceleration. And we put in the terms here. Come up with 30, okay? Write this on your paper. Time is equal to 30 divided by omega there. And that's 30 divided by 6.65 equals 4.51 seconds. And we do it again for the second 2.5 centimeters here, divided by the amplitude, 56, and that turns out to be 8.48 seconds. Now we subtract one from the other, and there's the answer. 3.9735 seconds is the time it takes to get from this to this in the simple harmonic motion system, okay? And then I show you, if you want to go back to see the answers again, you can go want to see the answers again quickly. And if you say no, you can go back to the new problem in the main, get my main manual. So anyways, go to my site, buy my program in Past Physics, and have a great day. Okay, this is time during the coronavirus baloney. I say it's baloney. If you're a mathematician, you certainly got to know it's baloney. 41 deaths in the United States, unbelievable, compared to 350 million people. So anyways, that's another program I'm going to do in probabilities. And don't forget about my calculus programs either. They'll both help you pass those classes, and you'll have them for the rest of your life as long as you keep the calculator. So have a good one.